Now I want to talk about the power. Okay, let's say P. In general, the power equals to the energy per unit time in general. So the average power equals to the total work done on the object divided by the time t. Okay, so it's in joule per unit second. Let's take the instantaneous power P at a at a special time equals to d omega per dt. Okay, and you know that the work done on the object equals to F dot the displacement. Let's say here we have dr. In this case, we have F has a constant value, so we can say F dr dt. dr over dt equals to v, is a velocity, okay? And vx equal dx over dt, and vy equals to dy over dt. So we can write F dot v. So we can take as a formula of the power equals to F dot v. Let's take a simple example to this notation. Example 7.7.12, page 204. Here we have a elevator attached by a cord, and here we have a motor to get up and down the elevator. Okay, inside, first of all, the mass of the elevator equals to 1600 kilogram. Inside we have a many person of mass equals to 200 kilo. The kinetic friction here, we have F kinetic equals to 4000 Newton. This F will resist the motion, the upward motion of the object. So here we have a motion in this direction, okay? And you know, down we have the total weight, which is equal M equals to M of the person plus M of the elevator. Okay, the question is, we have to find what power delivered by the motor is required to lift the elevator at a constant speed of 3 meters per second. So I have to find the power in general of the motor in order to have a speed of 3 meter per second. Okay, it's a constant speed. So in this case, A equals to 0. Okay, you see here we have the tension T up and down. The motion is up, so we have the kinetic friction F directed downward. In general, we have F, we have the weight mg. I'm talking about the object, okay? The object here. We have F, we have mg, and we have T. Equals to O. Equals to O because because V is constant. We do the projection. We have F and mg in the negative direction, minus F minus mg, and plus T equals to O. So T equals to F, or we can say mu. No, we have the value of F. Okay, we can keep it F. F kinetic plus mg equals to 4,000 plus m total equals to 1,600 plus 200. Here we have F equal, okay, times G 9.8. Okay, we get T equals to 2.16 times 10 power 4 Newton. Okay, now the question relates to the motor here. I'm talking about the motor. Here we have the tension T. The motor will use the tension to push up the elevator. So the power of the elevator equals to the force, I mean T, times the speed. This is the relation of the power, equal the force applied by the motor times the speed of the system. Okay, so here we get 1.16 times 10 4 times V, which is equal to I think I have its value, equal Okay, equals to 3 meters per second. We get finally P equals to 6.48 times 10 power 4. The unit of the power is watt. Okay, watt. This is the answer. Now, part B, we have to calculate the power if the motor will push up the elevator with some acceleration. Let's say A equals to 1 meter per second square. We have to find the power. We do the same calculation, but when we say T, when we talk about the object, T minus mg minus F equals to ma, because we have A. V is not constant. Okay, so T equals to M 600 plus 200 times 1 plus mg. Okay, we have times 9.8 plus F. We get T equals to 2.34 times 10 for Newton. So P equals to T times V. We get 2. Here the velocity, here we have a general case. P equals T 2.34 times 10 power 4 times V. Now we can say, for example, if V equals to 3 meter per second, we can calculate the power. The difference now between part A and part B is in part A, the velocity is constant. V equals to 0 at any point during the motion of the object. But in part B, V is not constant. V starts with V equal to 0, and the velocity will increase with the time. So in general, the power equal T times V. Part 1 or part A, T, we calculated T and we have V, but in part B, we calculated T, but V, it depends the problem. Maybe let's take here V equals to 3 meter per second. We get 2.34 times 10 power 4 times 3. We get 7.02 times 10 power 4 watt. As you see here, we have two values. When in part A, we have A equals to 0, V equals to 3 m per second, we get A power equals to 6 0.48 times 10 power 4 watt. In part B, A equals to 1 m per second, and we calculated P at the same velocity, 3 m per second. Yani when the elevator arrive to this value of velocity at a special time, okay? We calculated P equals to 7.02 times 10 power 4 watt. So the motor will consume more power to have acceleration. Okay? Thank you.